My name is Joe Grand. I'm a hardware hacker, product designer. Have been involved in designing DEF CON badges and various electronics things for quite a while now. This is my first academic paper in over 10 years, so I'm super excited to actually be here and be able to present this stuff to you guys. This talk is about basically techniques to deconstruct circuit boards and get access to inner layers of circuit boards to help with reverse engineering. And in interest of time, the paper goes into all sorts of detail about the different techniques and the results and quality of results and stuff. But I'm just going to show you lots of pretty pictures, just so you can kind of see, get a general sense of the process. The main goal of circuit board reverse engineering, it's sort of like, we think about reverse engineering software, we think about reverse engineering, whatever network protocols, or even at chip level, chip hacking. But this board level, circuit board level, has kind of been missed a lot of times. And we can get a lot of information out of PCB reverse engineering because if we are able to access each individual layer of the board, and we can process those, we can then get back an actual schematic, and from the schematic, we'll be able to actually, see the real electrical design. So yes, we can still attack firmware and things like that, but from an actual electronic board level, schematic level, like this is the way to go. So lots of different reasons to do it. Probably the most offensive would be to, if we want to analyze a design and maybe add malicious behavior to it, like our government's been doing for years. Now we know the techniques that they're using. So this presentation, this paper, is basically about the techniques to give you the layers. Some of the future work that I'm working on is to help automate the process of what to do once you get those layers. So perhaps a future presentation. So PC board construction, in a nutshell, basically layers of materials, whether they're conductive or insulating, and sort of creates this sandwich of material. You also have on top what's called a solder mask, which is basically a coating, in this case green, but it can come in lots of different colors, that basically prevents and protects any copper from being exposed that isn't intended to be exposed. So for the top and bottom layers, you're usually going to have a solder mask coating on there that we're going to need to get through to deal with those two layers. And then we'll want to get down to the substrate, through the substrate to the other copper layers underneath. You also have a silk screen layer that's on top of that gives you interesting engineering information that could be used for all sorts of other kind of hacking stuff. Substrate, copper weights, there's all sorts of different variations of circuit board fabrication. So some techniques are going to work better than others depending on if the board is simple or if it's highly integrated with lots of layers. Here's like a 16-layer board. One of the examples I use is an Apple iPhone 4 16 gig board. It's a 10-layer thick, 10-layer, less than 1 millimeter thick board. It's insanely complex. So I use that as sort of the state of the art. And some of these techniques are sort of obvious. So we're going to do some manual stuff with Sandpaper and other things. And some Ross Anderson and Marcus Kuhn have sort of pioneered in the chip level space. But there you're looking at very, very tiny spaces. And we're looking at pretty large areas. So not all of those techniques are going to work. So I'm going to just kind of bust through some of these. So we go through solder mask, removal, delayering, and then imaging, so non-destructive ways that we can actually see into circuit boards. All this work, by the way, was done for a DARPA Cyber Fast Track project, which was awesome because I was going to do this work anyway, and then I decided to just submit the proposal, and now they paid me money to do it. So it was awesome. So yeah, using Sandpaper, typical way. Just it turns out this is the cheapest, most effective way out of all of these different techniques, I think. Is just using sandpaper and kind of rubbing lightly to remove the solder mask and whatever surface finishes are on there, and you can get pretty decent results. 400 grit sandpaper. There's not a lot of wear on the board and stuff. So that was kind of a surprise to me. I figured the more advanced techniques would be better, but that's not really the case. Fiberglass scratch brush is used a lot for cleaning rust off of surfaces or off of cars. Sometimes you see it in the PC board rework kind of area of a contract manufacturer if they need to remove solder mask from a specific area. So in this case, it's it's great, but it's going to take you a long time to get through an actual full board area. Sandblasting. Usually, sandblasting and circuit boards don't go well together because sandblasting is a very abrasive process. You're basically shooting some sort of material at the board. But it actually works pretty well if you handle it properly. So here, if we're like 6 or 8 inches away, angled down at the board, we can actually remove all the solder mask from the board with a little bit of pitting on the actual copper, but no damage to the substrate if you do it right. If you don't do it right, you're going to shoot right through the board, which we did a bunch with the Apple boards just for fun. Which I should mention too, the Apple boards I got were on eBay, and they were obvious clones, but they were being sold as like, build these and fix your Apple phone or something. Really strange. I'll show you. There's actually a picture of one on the next slide. Chemicals are awesome and really scary. I don't have the picture of me in the full chemical suit, but I should mention this is my little chemical setup in my backyard at my old house in San Francisco, and I had a full chemical suit, respirator. But my backyard faces the back of a hotel. So all of the doors of the guest rooms face my backyard. And I can only imagine what the people were thinking when I was out there doing this. Yes. But it was being funded by the government, so I'm allowed to do it. So I use 2 different chemicals that are standard for PC board fabricators. Like if they mess up applying solder mask, this is the way they would get rid of it. Just not in my environment. They would have a more safe environment to do it. And the results are great. They strip the solder mask right off. If you leave the boards in the chemicals for too long, eventually the substrate will start to delaminate, which isn't necessarily a bad thing if that's the way we're going to get access to layers. Using lasers, another really awesome thing. I thought would be great for getting access to the inner layers, but it turns out it's not so great because laser energy actually reacts differently to copper versus the substrate, which is usually like a fiberglass epoxy. So if you just had like a laser going across, you would burn through the substrate faster than the copper. That's what we realized. But for removing solder mask, it actually is great. So here's a picture of just some time I rented on a machine. And just some single passes right across the board. These are found in all sorts of hacker spaces these days, so pretty easy way to do it. But still, using Sandpaper to me is still the favorite. Here's a picture of the iPhone. This connection right here is actually covered in solder mask, which tells you a lot of times if you're hacking a board and you see a connector under solder mask, you go, okay, that's probably something an engineer put there for development, and they just covered it over instead of trying to remove it. So from a hacking perspective, if we needed to accurately remove an area, then laser would be the way to go. So that was solder mask removal. Delayering, getting into the inner layers of boards is really where things become interesting. Here's a little time lapse. Again, using sandpaper, using a rubbing stone. I had a 4-layer board that I was using as kind of a test board. I had a bunch of them that I got at a surplus store. And it works pretty well to just kind of brute force, some blood and sweat to get down to the inner layers. And what you end up seeing is just, if you're sanding improperly, you kind of get some wearing around the edges, but it's totally fine. Because once you get access to something like that, you can image it, you can post-process it, get it to a nice state to help you then get to that next step of full reverse engineering. So next one is Dremel tool. I don't have a video of this one, but similar sort of, instead of a manual abrasion, you're mechanically mechanically wearing off the surface. This is the 3rd layer down. So the previous video was the 2nd layer. Now we're on the 3rd layer of this board. And you can see I'm not very good with Dremel tools. So it takes a little bit of practice to kind of, gently get down to the layers, which is why, again, sandpaper, like just using your hands in sandpaper is surprisingly good. You have much better control. CNC milling. This is one that I should mention too. I got a lot of these ideas off the internet, and people are very vocal on the internet, and they're like, you should use the sandpaper with the blah blah blah, or you should use the hydroethanol ploxy chemical or whatever. People just say all this stuff but don't actually test it. So it was actually fun to test some of this stuff and see if it worked. But everyone was like, oh, you could use a milling machine to just mill off the layers, which seemed great and actually worked pretty well. But a trick with CNC and with most things that are very accurate is that PC boards are not planar. They're not completely planar as you would imagine. They look like it, but when you have something that has like a 0.1 thousandths of an inch adjustment and is super planar, and then you put a board on there that's if you look at it on a microscope, it's a little bit wavy. You're not going to always get nice clean access to each layer. So with the milling machine, it worked great, and I basically had, here's my setup. I had a T-Tech quick circuit PC board prototyping machine, basically set up a little area of the board to mill out, but once I could start seeing the next layer under the substrate, I just used the fiberglass scratch brush to manually get down. Otherwise, you wouldn't ever be able to get a totally flat result. So here, 1, 2, 3, 4 of the inner layers of this 10-layer Apple board. It was a small area, like one to like 1 by 1.5 inches or something like that. So you'd have to go through the steps to get a full board, but totally reasonable. And for a board like that this took me a few hours to do, and for a board like of that complexity, was awesome using that milling machine. Super cool. Surface grinding, again, not something that you normally will associate with circuit boards. In this case, gigantic machine shop in a very scary part of Oakland, California, where I actually had to be escorted to my car when we were done with the work at like 9 p.m. And they even offered to have me park inside the machine shop. So I went there with some circuit boards, and these guys deal with big, large metal things, not small circuit boards. But we had a lot of fun that night and built up a little holder for the circuit board and stuck it through this machine. And these surface grinders are even more accurate than a PC board prototyping machine. What's the spec? Oh, yeah, 0.1 mil increments, so 0.1 thousandths of an inch you can move down layer by layer. Same issue, though, is that boards aren't totally planar. But what's cool about the surface grinder, since they also are designed to put nice surface finishes on things, is that you can get an awesome surface finish and not even need to expose fully the copper. You can just polish the substrate right above it and get a nice image of the inner layer without having to get directly down to it. So that's what we did. There's more layers of that board. This is a 6-layer test board. But yeah, super cool. So then on to imaging, some non-destructive methods, because most of these assume that you have no components on the board, which is okay if you have more than one to mess with, but sometimes you have assembled ones. Standard 2D X-ray, sort of an obvious type of thing, but not really that great. Usable for kind of general purpose, simple boards. Here's a 4-layer board that I designed. I have some layer numbers up there, so you can get general information about a board using X-ray. But it gives you a composite image. So everything is basically on a single image. So you can't tell what layer these connections are. You can see vias connecting different layers together, but you don't know where they are. So it's only okay if you can, like, just from a general point of view, if you want to move around the field of view and move the angle in real time to get a general sense. But it's not really going to give you what we're looking for is actual images. Here's another example of the iPhone board with parts on it. But it was still worth doing to kind of let us know, if that was the only option, then you could go with that. But really, 3D X-ray CAT scan, where this is commonly done for analyzing like ball grid array, BGA solder balls underneath parts if there's failures. In this case, we ended up going to a place with a test board of mine. We stuck it in an X-ray machine that had this CAT scan functionality, which basically takes lots and lots of different 2D images at different angles, and then post-processes all of that and gives you slices back. So here's this video of us slicing through the board from top to bottom, and then it goes, bottom back to top, where we can see each individual layer of the board in that case. So really, really pretty cool. And here's like the little final picture of that. So here's the actual X-ray, and then here's the real PC board design Gerber plot that I had already had, so you can kind of compare the two. And again, this is a small area, like the milling machine, a small area, so you have to do multiple segments to get good resolution. But it actually surprised the owner of this company, who specializes in failure analysis and has this, $250,000 X-ray machine, who had never actually done this type of work before. So now we know it's possible. The results will vary depending on the thickness of the board and the composition and copper and all of that stuff. But just amazing, like really, really kind of cool stuff. So the probably the most important part of the paper is this characterization matrix, and that's going to show you the different techniques that worked, time it takes, the cost, how easy is it to do, how easy is it to get access to equipment, because every situation is going to be different when you're analyzing boards, when you're hacking on stuff. Sometimes you might be overseas and only have access to certain things. Sometimes you might be in a university and have access to better equipment. So it all depends. So I thought that this matrix was important. A lot of the techniques that didn't work are on a presentation that will be on my website. So if you are curious to see stuff that didn't work, then you can go up there. And I'm going to put up a bunch of other videos and stuff as well. So that's the paper in 15 minutes. And I guess, do we have time for questions? Sergey says yes. Okay. Any questions? No? Oh. Do you have one, FX? Yes. Ooh.
Yeah, this is Rick, actually. So my question is, what exactly would you be looking for at the PCB board layer? Are you like looking for bits that are going to be set high or low so they become some kind of default value and you can't see that?
Yeah, so you can look for lots of different things. The main kind of high level is looking at the actual just way what the electrical design
what's connected
is.
to what? Yeah.
And with what's connected to what could possibly be the state of pull-up resistors or the state of current system, or maybe if there's configuration resistors in there. It could also be, some boards actually have components built into layers, which I don't discuss here, but sort of higher end boards can have resistors and capacitors built in, so maybe you'll be able to identify things there. But yeah, so it sort of depends on the board design, but it really comes down to what the goal of the attack is in the first place. But you'll end up seeing everything that electrically is there, you'll see it. And that's going to be that's going to give you that extra information. Maybe it's going to give you a clue about, oh, a memory device is actually connected to this thing. I want to attack the memory, or I want to attack the firmware. I found maybe there's a connector, a hidden connector that's a JTAG interface. Now we're going to go through that. So with a board, you can sort of try to hide stuff, but it's really just obfuscated. So once you can find it, then you can further your attack.
Okay, that's good. Thanks.
Cool.
Hello.
Hi.
For the methods where you use CNC or laser, did you actually try devices that also had like distance measurements? So like the CNCs I was like in a professional school educated on, they could tell like how far they're away from the surface, which would kind of like you would not go flat out, but you will kind of like surface surf.
Right, like to adjust for the non-planarity of the thing. Yeah, so I didn't do that with the CNC machine, but the surface grinder has a way to do it, but we didn't actually try to follow any sort of contour of the board. We just kind of sliced across it. But yeah, that might be an option. I don't know how accurate those are.
They're laser measurements usually.
So so I mean that's a possibility.
It's like I don't know about inches, but it's like 1,000 thousands millimeter.
Yeah. So that's worth checking into. I'm sure it would probably be helpful.
Cool.
Yeah.
Since the layers are glued together, have you tried any chemical solution to delayer the PCBs?
Yeah. So there was a bunch of chemicals that I tried to delayer them. None of them worked, which is why none of them were in here. Though there was one that somebody mentioned to me after this work was done. I can't remember the name. Might have been methyl ethyl ketone. I can't remember. That will potentially soften the adhesive enough for you to peel them apart. But it's still at that point, I'm not sure. And sort of the dangerousness of it outweighed a lot of just the usefulness of it, which I think a lot of times, if you have to do chemicals, then if that's your only way, then it's good. But if you don't, if there's other options, then it's sort of like, I didn't really want to set up again to try to do that one. But I think there is one chemical, and it might be methyl ethyl ketone, that's designed for dissolving epoxies, that if you leave the board in there enough, it will probably delayer.
So I'm guessing a bunch of people suggested this, but did you try just using a belt sander? And
yes, a belt sander, drum sander sort of thing. I'm not very good with machines like that, which is why I went with the surface grinder instead, which is basically the same technique. But yeah, a drum sander, belt sander, also that's how I was trying to emulate with the Dremel tool, will be good as long as you have good enough control of the board going through. Because if you're on a drum sander and you slip, you're going to eat right through. Between the copper layers is super thin. So if you're good at it, yeah, it will probably work. Cool. All right. Well, thanks.